Homework 11, question 3, part B. Again, this question asks us to figure out what element was oxidized and what element was reduced, if any, and then identify oxidizing agent and reducing agent. Let's start by assigning oxidation states. HCl, that's hydrochloric acid. It's a covalent compound. The more electronegative atom, of course, is chlorine. Hydrogen would take whatever charge is needed to make the overall charge neutral. Well, we can do this one in our head. There's one atom that's -1. It's going to pair up with one atom that's +1 in order to make an overall neutral compound. NH3, ammonia. The more electronegative atom is nitrogen. Nitrogen takes its normal charge based on position in the periodic table, and all elements in column or group 15 take a -3 charge. Hydrogen would take whatever charge is needed, we'll call it X for now, so that when the oxidation states are added together, it'll match the overall charge of the compound, which, since nothing is written to the upper right of the chemical symbols, we know that it's implied to be 0. A little bit of algebra will enable us to get to an answer. One atom of nitrogen, whose oxidation state is known to be -3, when added together with the 3 atoms of hydrogen, whose oxidation state is unknown, should match the overall charge of 0. We'll add 3 to both sides, and we'll divide by 3. X works out to be 1. So in this case, hydrogen's oxidation state is +1. The last compound to consider, NH4Cl. Here, hopefully you recognize the polyatomic ion ammonium. Ammonium ion should be separated out. So let's rewrite this as NH4 plus, and then separately Cl minus. When chlorine is alone and it bears a -1 charge, its oxidation state is -1. For the other ion within that compound, the ammonium ion, we'll consider which atom is more electronegative. Between hydrogen and nitrogen, nitrogen is the more electronegative atom. That means that hydrogen will take whatever charge is needed, so that when the oxidation states are added together, we get the overall charge, which is non-zero in this case. It's a +1. We'll do a little bit of algebra. One atom of nitrogen, whose oxidation state is -3, when added together with the 4 atoms of hydrogen, whose oxidation state is unknown, should be equal to the overall charge, which is a +1. We'll neaten this up a little bit. -3 plus 4x equals 1. We'll add 3 to both sides. 4x equals 4. And x works out to be 1. Now, let's summarize up above what the oxidation states for each of these elements are. +1 for the hydrogen within hydrochloric acid, -1 for the chlorine. -3 for the nitrogen within ammonia, +1 for the hydrogen. -3 for the nitrogen within ammonium chloride, +1 for the hydrogen, -1 for the chlorine. Now, what element experienced a change in oxidation state in going from the left side to the right side of the equation, if any? Well, hydrogens within hydrochloric acid on the left side is a +1. Hydrogens within Ammonium on the left side is a +1. Hydrogen's oxidation state within ammonium chloride on the right side is also a +1. There's no change. +1, +1, +1. Hydrogen was neither oxidized nor reduced. Next element, chlorine. Within hydrochloric acid, chlorine has a -1 oxidation state. On the right side of the equation, within ammonium chloride, chlorine has a -1. Exactly the same. -1, -1. There's no change, and therefore chlorine was neither oxidized nor reduced. How about nitrogen? On the left side of the periodic table within ammonia, nitrogen's oxidation state is -3. On the right side of the equation, within ammonium chloride, it's also -3. No change. So nitrogen was neither oxidized nor reduced. None of the elements in this reaction were oxidized or reduced. So this is not an oxidation-reduction reaction. When you select that, WebAssign wants you to write none for all of the boxes. N-O-N-E, none.